Hello viewers, Alan here. Today I'm going to fix a problem that's been bugging me for nearly a year. I use a pole to hang my cameras and screens and things on, and it's a horrible lash up that was done in a hurry, and it's horrible. Time to replace it. So I'm going to make a new one today, and I'm going to use this old discarded disc rotor, a couple of bits of tube that are prepared to play hide the sausage with each other, and some other bits of scrap. Let's get to it. Okay, so this is the rather ugly duckling that I use at the moment. It started off just as a workshop stand at this height, and I've bolted this piece onto it, turned it into Frankenstein's monster. So this gets in the way all the time, so does the base, and it doesn't stand properly half the time. So it's really a dog's breakfast, and it's a hack on a hack on a hack, and I think it's time to do something a bit better. So looking at the new setup, I'm using my phone, so I have to stand a mile back to get the whole thing in. So let's start moving in a bit closer. But you'll notice that cross piece is gone. The base now happily sits on this really uneven rubber mat surface, and the pole is slimline, so I can move it right up next to any of the machines. The battery has got a proper home, so I've made this sheet metal pocket so it's easy to get the battery out to charge, and it just hangs on a single bolt, which obviously can fit onto any of the holes in the upper piece. So it might be worth noticing these pop rivets. They're actually countersunk head pop rivets, so you drill a countersunk hole in the sheet metal and the head pulls right in. There's just nothing sticking in at all, which is of course exactly what I wanted in this situation. So it doesn't get in the way of the battery at all. So that's a lot better than the zip tie I had, which was always a bit of a pain. And I've got a big height range here now, and I added a camera mount on the top. I guess that's about it. So that's it seems to be working pretty well for me. But let's have a look at some of the construction details. Just a quick look. I'm not going to do a full blow by blow. Let's start off by putting the scrap disc rotor into the lathe, so I can clean up the bottom of what will be the bottom of the rotor, so it's flush across at the and will sit flat on the floor. Don't care what the dimension is here, it's just got to sit on the floor, but nonetheless it's the first time I've tried to machine a disc in the lathe, so it'd be an interesting exercise and see what sort of quality of finish I get on the cut and so on. And to improve the odds that the thing will sit flat on the floor, I'm going to relieve that piece in the middle out a little bit so that it's lower than the outside edge. Oh, that's not a pretty good finish. Certainly good enough to be the base of a floor stand. I've just got to do a bit of deburring in a couple of places. So to make up the 3mm difference between the thickness of this piece and the size of the hole in this tube, I welded on, or just tack welded on, a piece of 3mm thick material on the end of the sliding piece, and in the end of the tube I fixed another 3mm thick piece of steel, which you can just see, I think, there. Just held in place with a couple of screws that obviously don't go quite all the way through. They're just tapped into that, and that creates a good fit at this end and that piece, and that piece causes a good fit inside the body of the tube. So we'll put it together. So that's going to slide in there, slide all the way down. And obviously come out the other end, so you can see now how that's taking up the space here, and inside the tube that other piece is doing on the end of this is doing the job. Those two 3mm pieces just take all the slop out of it, so it's actually slides quite nicely. It's not exactly a trombone slide, but it actually turned out better than I was expecting. And to fasten the other end to this disc, which we've machined to make it flat on the bottom, just a couple of pieces of angle iron. It's pretty self-explanatory, I think, and a couple of bolts that go right through. And I used the DRO to calculate the coordinates for the 6 bolt holes based on a 4.5-inch pitch circle, and then mapped them directly onto the backs of the angle irons. So I'm not going to bore you with showing you drilling holes and all the rest of it, and the assembly was simple enough. I bolted this piece on first, put these, this one's just sitting here loose, the other piece is sitting here loose. We tighten these up to pull the two halves of the bracket together. Trying to do it keeping my hands out of the way. Right, then tighten the back 2 bolts, and that's it. And of course it's a lot more stable on this sort of surface than the other thing was, where the feet kept finding holes to get into and it would just never behave itself. And also, as you can see, it can move and stand right up close to the machines now, which is a much better idea than what I had before. So this is probably the main attachment point to the pole. It's an L bracket with a pair of holes drilled in it that match onto the hole pattern up and down the length of the pole, so it can be at any position or either way up. The GoPro happily sits on it with its magnetic clamp, so that's easy. And then I've got that, it's a sort of a universal arm which is meant for holding a dial indicator, I suppose, a dial test indicator. But I've repurposed to hold a remote monitor, so that when I'm in front of the camera I can see what it's actually capturing at a size that my old eyes can make sense out of. So that's it, folks, a quick and easy project that should make pole dancing in the workshop a lot more fun. Thanks for watching.